Miss Miklos here, and today we are talking about three topics. We're talking about how to add and subtract fractions. We're also going to talk about complex fractions, and complex fractions are probably the new part of this lesson today. In order to add and subtract fractions, we know that we need to have a common denominator. And in order to do that, we need to find the least common denominator, and we're going to practice that before we actually get into our problems. So if you haven't done so already, please open up this note handout that is on Maiolu, just because it'll kind of help guide you and help you see where we need to go. So if we look at this first problem, it's just asking us to find what is the LCD of these two values. And we're asking what is the prime factorization of 8. And a lot of you guys have never really heard that terminology before. So if I'm taking 8, what it means if I'm doing a prime factorization is I would make this into a factor tree of 2 times 2 times 2. So I'm going to say that the prime factorization is 2 cubed. If I did a prime factorization of 6, it would just be 2 times 3. So we need to look at this and see what prime factors do they actually have in common. And if I look here, I notice that they have one of these 2's in common. So I'm going to say they have a 2 in common. And what else do they need to get the LCD? Well, they need 2 more 2's and another 3. So our LCD here, we are going to have to take what they have in common times what else is left over. So I need to think, what is 2 times 2 times 2 times 3? And it ends up being 24. And my guess is, back in Algebra 1, you guys were pretty good at finding the LCD of numbers like this. And we probably didn't think of prime factorization, but these are probably terms and terminology that your Algebra 1 teacher used. We're actually going to think of it in a slightly different way. What we're doing, we are finding the LCD by taking the highest power of any base and multiplying them together. So what I mean by that, if we look at the prime factorization, I notice we only have 2 bases. We have 2 and we have 3. The highest power of 2 is 2 cubed. The highest power of 3 is 3 to the first. So when I do 2 cubed times 3 to the first, I end up getting 24. So 24 is our LCD. So, using that method, we want to go ahead and do number 2 together as well. So we need to figure out what is the prime factorization of 12. So if I broke down 12, I would get 2 times 2 times 3. So if I write this as prime factorization, I'm going to say it is 2 squared times 3. What is the prime factorization of 20? So if I broke down 20, 20 would become 2 times 2 times 5. So I would get 2 squared times 5. So now, to find the factors that form the LCD, I notice this time I have 3 different bases. I have 2, I have 3, and I have 5. Now, I need to take the highest exponent of each base. So if we look at the 2's, I notice the highest exponent is 2. 3, the highest exponent is 1, and 5, the highest exponent is 1. So if I multiply these values together, I get 4 times 3, which is 12. 12 times 5 is 60. So 60 is the smallest number that both 12 and 3 go into. If we look at number 3, all of a sudden this gets a little bit more complicated because we're adding x's in. So if I think of 3x, my prime factorization of that would be 3 times x. If I thought of 9x, it would be like 3 times x, or 3 squared x. So looking at these, I notice we only have 2 bases, 3's and x's. So I know that I'm going to have to take a 3 and I'm going to have to take an x. The highest exponent of 3 is 2. the highest exponent of x is 1. So when I multiply those together, our LCD would be 9x. Number 4, we just have x's and y's, and I actually think this is the easiest one to do because it is already in prime factorization form. In fact, I noticed that we only have 2 bases, x and y. My highest exponent for x is squared. My highest exponent for y is squared. So that LCD would be x squared, y squared. Hopefully, continuing to go through this, it's becoming a little bit easier if you were struggling with prime factorization or if you are someone that ever struggled with finding an LCD. When we get to number 5, all of a sudden we have some issues because I do not have monomials anymore. We have binomials. So I have to think, what are the factors of x squared minus 1? And I know that we would factor that into x plus 1 times x minus 1. Then I need to think, what are the factors of x plus 1, because that is this denominator. And in fact, x plus 1, we would say that is prime because nothing else goes into it. So we will just leave that as x plus 1. Just a reminder that the definition of a prime number is that a value is only divisible by 1 and itself. Okay, so if something's prime, the only 2 things that it's divisible by are itself and 1, which that's what makes this true. So if we look at this, I notice we only have 2 bases. I have an x plus 1 and I have an x minus 1. I also notice that both of them, the highest exponent is 1, so my LCD is x plus 1 times x minus 1. And some of you may have wanted to write that as x squared minus 1, which is correct. However, it is much, much better to write it in factored form. And the reason is, it makes it a lot easier to actually get our LCD. And what I mean by that is if we look at these terms and I look at an x plus 1, if my LCD is written out this way, I notice, oh, that is missing an x minus 1. Where if this was written as x squared minus 1, that would be a little bit tougher to do. So now we're going to go through number 6. Number 6, I'm going to have to factor both of these. And x squared plus 4x plus 4 is x plus 2 times x plus 2, or x plus 2 squared. X squared minus 4 is x plus 2 times x minus 2. And then x minus 2 is just x minus 2. So some things I noticed, once again, we only have 2 bases here, x plus 2 and x minus 2. However, this time, we have some higher exponents. If I look at all my x plus 2's, I notice that my highest exponent is squared. If I look at all my x minus 2's, I notice the highest exponent is 1. So my LCD here is the quantity x plus 2 squared times x minus 2. For number 7, 6x squared, I'm going to think of that as 2 times 3 times x squared. 4x squared minus 12x. I can take a 4x out and I'm left with x minus 3. So this is like 2 squared x times x minus 3. So to find our LCD, I notice we have 2's, we have 3's, we have x's, we have x minus 3's. Those are all the factors we have. Now I need to look and see what is the highest exponent. For 2, I have 1 and I have 2, so it's going to be 2 squared. For 3, I just have 3 to the first, so that's what it's going to stay. For x, I have x and x squared, so I need to put in a squared. And for x minus 3, I just have x minus 3, so that's going to stay as well. So when I multiply these together, 2 squared times 3 is 12 x squared times x minus 3. So that would be our LCD. Number 8 looks really tough. However, it is easy again. All of a sudden I have hearts and stars, and my highest exponent for hearts is squared, and for stars is cubed. So happy Valentine's Day to everyone with that little heart there. So now let's transition into simplifying. And just a reminder, before adding or subtracting fractions, our denominator needs to be the same. So number 1 is a really easy example because I noticed they have the same denominator. So I am going to keep my denominator and add my numerators together. I notice that I cannot simplify this any further, so 3/5 is my answer. Now on number 2, I notice I do not have a common denominator. So I need to think, what would our LCD be? And our LCD here would be 4 because that is the smallest number that both 4 and 2 go into. So in order to make 1/2 have a denominator of 4, I'm going to multiply by 2 over 2. Just a reminder why I need to use 2 over 2 is because since this is an expression, I'm simply multiplying by 1. So I have 3/4 plus 2/4, which is 5/4. And we always want to leave that as an improper fraction. Mixed numbers are gross and yucky, so leave it like this. Number 3, our LCD here. Because we definitely do not have a common denominator, so our LCD would be 6, because that's like 3 times 2. That's the smallest value they both go into. So this time, I'm going to have to multiply 2/3 by 2 over 2, and I get 4 over 6. And I'm also going to have to multiply 1/2 by 3 over 3. So I get minus 3 over 6, which is -1/6. So that is my final answer there. So that really is like an Algebra 1 review, just dealing with numbers all in themselves. Now, if we look at number 4, here all of a sudden we have some variables. However, I notice they have a common denominator. So I can add these together and I get 9 over 3x. And we can simplify this further because they have some common factors. Okay, we have not seen common factors yet. 9 and 3 we can reduce, so our answer becomes 3 over x. So number 5 here, this is really what our problems are going to look like. So the very first thing we need to do is find the LCD, and we already learned we need to do that by factoring. So when I look at 3x cubed, that is just going to be 3x cubed. When I look at 6x cubed plus 3x squared, I notice we have a GCF of 3x squared times 2x plus 1. So if we look at this, I notice that we have 3 different bases. We have 3, we have x, we have 2x plus 1. So my LCD is going to be 3x cubed, because 3 was the highest exponent for x, times 2x plus 1. Now we need to go ahead and get common denominators. So I'm going to look at this first fraction and compare to the LCD what factors are missing. Okay, so our LCD is 3x cubed times 2x plus 1. I notice I have 3x cubed. I am missing 2x plus 1. When I look at my second denominator, I notice, okay, yeah, I have a 3. I have an x squared, but we need an x cubed, so I'm going to say we're missing an x. And I have a 2x plus 1, so we're good there. So what this tells us, it tells me that I need to multiply this first fraction by 2x plus 1 over 2x plus 1. It tells me I need to multiply this second fraction by x over x. So I have 4 times 2x plus 1 over 3x cubed times 2x plus 1 plus x times x over 3x squared times 2x plus 1 times x. So the first thing I notice is that these are exactly the same, so I can write that as 3x cubed times 2x plus 1. I also notice that we need to simplify this more. Okay, so I really am going to add them together, so I'm going to say 4 times 2x plus 1 plus, and I'm just going to write that as x squared because we know x times x is x squared. I need to simplify this further, and the reason why I know I need to simplify further is because we still have addition here. If this is all in terms of multiplication, we would be good. So I need to go ahead and distribute that 4. So I get 8x plus 4 plus x squared over 3x cubed times 2x plus 1. Now, I want to leave my denominator like this, okay? This is the best way to leave my denominator because I need to check and see, can we factor this numerator? And the reason why I want to double check that is this is now a problem like we learned in the last lecture. And I need to make sure that it is simplified. I know things are simplified if there are no common factors. So looking at this, are there any factors of 4 that add up to be 8? And there are not. So x squared plus 8x plus 4 over 3x cubed times 2x plus 1 is our final answer. Okay, so number 6 here, once again, I notice that I need to get a common denominator, so I'm going to begin by factoring these two denominators. If I look at a squared plus 4a plus 3, I know it's going to be a, and I think a plus 3, a plus 1 would work. A squared minus 9 is a plus 3 times a minus 3. So if we go ahead and take a look here, our LCD is going to be x plus 3. I don't mean x. I don't know why I said that. It's going to be a plus 3. So a plus 3 times a plus 1 times a minus 3. Because those are the 3 different bases that we saw in our common factors here when we did our prime factorization. Okay, and I noticed that 1 is the highest exponent. So that would be our LCD. So if we look at this first term, I notice that I am missing an a minus 3, so that's what I'm going to have to multiply by. This second term, I am missing an a plus 1, so that's what I'm going to have to multiply by. Okay, so then I'm going to have a minus 3 times a minus 1 over a minus 3 times a plus 3 times a plus 1 plus a times a plus 1 over a plus 3, a minus 3, a plus 1. And at this point, it can be super, super tempting to start crossing stuff off. Because yes, we have like terms, but obviously we have common factors. I put them there, okay? I chose to do that in order for us to get a common denominator. So now I can write this as a minus 3 times a plus 3 times a plus 1 in our denominator. I'm going to do 2 things at once here. I know my numerator is going to be this plus this, but I need to FOIL this out and I need to distribute there. So when I FOIL, I get a squared minus 4a plus 3 plus, when I distribute a to a plus 1, I get a squared plus a. So now we need to go ahead and combine our like terms. So I get 2a squared minus 3a plus 3 over a minus 3 times a plus 3 times a plus 1. I need to double check if we can factor this further and specifically see if one of these factors would cancel out something in our denominator. So just to recall, a quick way to figure out if something with a leading coefficient other than 1 is factorable, I can do 2 times 3, which is 6, and think, are there any factors of 6 that add up to be negative 3? And there aren't, so I know that this is going to be my final answer. Okay, so number 7 here, we're doing the same exact thing. I need to combine these, so I need to get common denominators. So we're going to start by looking at those separately and seeing what we can do. So I know h squared plus 4h plus 4 is h plus 2 times h plus 2, which is h plus 2 squared. And even if you wrote it out, h plus 2 times h plus 2, remember we're trying to write it in prime factorization, which means the base to the exponent. So I would then convert it into this. H squared minus 4 would become h plus 2 times h minus 2. So if we take a look at this, I notice that my LCD has two terms in it. It has an h plus 2 and it has an h minus 2. Now I need to look at factors, I need to look at exponents. So looking at h plus 2, I notice my highest exponent is 2. H minus 2, my highest exponent is 1, so this would be my LCD. So in my first fraction there, I am actually missing h minus 2 over h minus 2. In my second fraction, I am missing an h plus 2 over an h plus 2. So I have h minus 2 times h plus 1 over h minus 2 times h plus 2 squared. I don't know why some of my h's are looking like n's here. Okay, minus 2 times h plus 2 over h plus 2 squared h minus 2. So I now have a common denominator, so I can just write this denominator. Remember, since this is multiplication, our commutative property exists, and it does not matter the order that I write it in. I need to FOIL here, so when I FOIL, I get h squared minus h minus 2. And over here I'm distributing, but it is important to realize I'm distributing a negative 2. So I get negative 2h minus 4. So looking at this, I need to combine all my like terms. So I have h squared minus 3h minus 6 over h minus 2 times h plus 2 squared. I need to see, are there any factors of negative 6 that add up to be negative 3? And there are not, so this would be my final answer. Okay, notice my answer is just simplified because I'm adding those fractions together. This fraction is simplified because we have no common factors in the numerator or denominator. So the majority of your homework tonight is on what we just went through, and that should all have been pretty review for you guys. Now, moving on here, we're going to start talking about division, and we're starting with some really easy problems here that should be super familiar. In fact, we talked about this in our last lecture, but when I'm dividing, that is like multiplying by the reciprocal. So I would get 4 over 6, which reduces to 2/3. Okay, so something like this is actually pretty straightforward and simple, and of course our problems aren't going to be that easy. But now I want to look at this because for some reason this tends to freak us out. But just a reminder, this is saying 1/2 divided by 3/4. It is the exact same problem as our previous problem was. So when I see this division bar, this fraction bar, we know fraction means division. So when I multiply, once again, I get 2 over 3. So now we're going to use this concept in a bigger picture dealing with what we call a complex fraction. And this actually is a simple version of a complex fraction. A complex fraction means I have a fraction in the numerator and a fraction in the denominator. So basically, it's a fraction of fractions. So if we look at number 10, this is really what a complex fraction on our level is going to look like. Okay, and the first thing I want to talk about is what is the numerator, what is the denominator? And our numerator here is going to be 2 over x plus 2. And my denominator is 1 over x plus 2 plus 2 over x. Okay, so my numerator is up here, my denominator is down here. And we're going to learn two methods to go ahead and simplify this. Method number 1 is actually going to be very similar to what we did earlier today. So the way that I am going to use here, I'm going to simplify the numerator and the denominator like they are two separate problems. And then once they're simplified, I'm going to go ahead and divide them. So if we look at this numerator, I notice that it's fine. Okay, it is simplified. But in our denominator, this is not simplified. Okay, because we have fractions, and I believe my LCD here is going to be x plus 2 times x. Because x plus 2 is one factor, x is a second factor. So I'm going to multiply by x over x, and multiply by x plus 2 over x plus 2. So I have 2 over x plus 2 over x times x plus 2 plus 2 times x plus 2 over x times x plus 2. So if I'm simplifying this, I'm leaving the 2 over x plus 2 still over x plus 2x plus 4 over x times x plus 2. So now looking at this, it appears that this is simplified because I can't do anything more with x plus 2x plus 4. So when I rewrite this, I end up with 2 over x plus 2 over 3x plus 4 over x times x plus 2. Now I know that I am dividing, so I'm going to multiply by the reciprocal. And I notice that we have some common factors to cancel out. And I'm left with 2x over 3x plus 4. So if we zoom back out, we can kind of see this method once again. Okay, so first thing I did is I tried to simplify the numerator and the denominator. Once I simplified the numerator and the denominator, like right here, then I went ahead and instead of dividing, I multiplied by the reciprocal. I will be honest with you guys, this is actually not my favorite method. I prefer method number 2. And we are going to go through that right now and see how we go ahead and use that. Now, the reason why I showed you this method first is because this is really building off of what we just learned. Method number 2 is going to be kind of a preview for something we will do in the next lecture. So our second method here is by multiplying by the overall LCD, and this is a new concept. What I mean by that is we have 3 denominators. The overall lowest or least common denominator of these 3 terms is going to be x times x plus 2. And what makes this a little bit different, instead of trying to get a common denominator, I'm going to multiply everything by this LCD. So I'm multiplying both my numerator and my denominator by x times x plus 2. I wrote over 1 just so I remember that I'm multiplying this by the numerator. So I get 2x times x plus 2 over x plus 2 over x times x plus 2 over x plus 2 plus 2 times x plus 2 over x. And looking at this, I definitely can see that some things are going to cancel. I have my x plus 2's, my x plus 2's, and my x's. So I'm left with 2x over x plus 2 times x plus 2, which becomes 2x over x plus 2x plus 4, or 2x over 3x plus 4. So notice I get the same exact answer. In my opinion, this is just a little bit easier to work with because I'm eliminating fractions instead of having to simplify them, which I personally prefer to do. Now, we get the same answer regardless, so it does not matter which method you guys use. Use whichever you are the most confident in. Okay, so here we are with number 11. And I'm going to go ahead and model this both ways once again just so we can kind of see what to do. So the first method, once again, is to simplify the numerator and then simplify the denominator and then divide. So I'm noticing for my numerator, my LCD should be x minus 4. So I'm going to have to multiply this by x minus 4 over x minus 4, which gives me 3 over x minus 4 plus x minus 4 over x minus 4 over. In the denominator, my LCD is x minus 4 times x plus 1. So I'm noticing I'm missing an x plus 1, and over here I'm missing an x minus 4. So I'm going to get x plus 1 over x plus 1 times x minus 4 plus 3 times x minus 4 over x plus 1 times x minus 4. So now I have common denominators, so we can add things together. So my numerator really becomes x minus 1 over x minus 4 over, when I distribute this, I get 3x minus 12, so I get 4x minus 11 over x plus 1 times x minus 4. So now I need to go ahead and simplify this further. So I'm going to divide or multiply by the reciprocal. And I notice that we have these x minus 4's in common, so I am left with x minus 1, x plus 1 over 4x minus 11. Okay, that is my final answer. There's nothing else that we can do. If you guys wanted to write that as x squared minus 1, that would be equivalent. But know that we don't need to go ahead and FOIL things out. This is a perfect answer. Okay, now let's use the second method. My overall LCD is going to be x minus 4 times x plus 1. So that is really what I'm going to distribute to every single one of these terms. So I have 3, and I'm going to do a little shortcut here. I notice my x minus 4's are going to cancel out. So I'm left with 3 times x plus 1 plus x minus 4 times x plus 1 over. When I distribute here, I notice my x minus 4's are going to cancel out again. So I have x plus 1 plus, when I distribute, I notice the x plus 1's are going to cancel. So 3 times x minus 4. So now I'm going to have to go ahead and FOIL and go ahead and distribute things. So that's what I'm doing right now. I'm distributing that 3. And now I'm going to see if there are any like terms I can add. So I notice I have x squared. My x's cancel each other out. 3 plus negative 4 is negative 1. In my denominator, I have x plus 3x, which is 4x. 1 plus negative 12 is negative 11. And this is the exact same answer as we previously got. Remember, we could also write this as x plus 1, x minus 1. Now, I've said previously that we always need to see if we can factor this. And just to stress why, it's in case we had x plus 1 or x minus 1 down here in the denominator. If that was the case, then I would have to write it this way so we could simplify it further. Since I cannot simplify this further, I can leave it just like this, and that is totally fine. Okay, for our last example, I am only going to use the method that I prefer, just to save us a little bit of time here. And when I'm looking at these, I notice something interesting. Yes, once again, these are opposites, so this is like negative b minus 1. Okay, so my overall LCD here is going to be negative b minus 1 times b. So that's what I'm distributing to everything. So when I distribute to this numerator, the b minus 1's cancel out, so I'm left with negative 2 times b. In the denominator here, when I distribute to that 4, the negative b minus 1's cancel out, so I am left with 4b. When I distribute to this final term, my b's cancel out, so I'm left with minus b minus 1. So if I'm simplifying this, okay, I have negative 2b over 4b minus b plus 1. So negative 2b over 3b plus 1 is my final answer. Okay, so once again, I personally think this method saves us quite a bit of time and effort. Okay, but if I had gone through this using the other method, we would have gotten the exact same answer. So the whole point here is that in order to simplify these complex fractions, we have two different methods that you can use. Use whichever one you feel most comfortable with.